Hey TSConf, thanks for joining me for my talk where we're going to decode some perplexing TypeScript. My name is Daria Caraway. I'm a senior UI engineer at Netflix where I work on some really fun React applications. And I've been an avid lover of TypeScript since about 2014 when I first started using it. And there's so many reasons why I love TypeScript. I find for me, it helps me catch bugs faster because I can catch them at compile time instead of runtime. I love that it allows me to bake in additional context directly into my code and I can use it as a communication tool. And the developer experience when uptaking external libraries is unbeatable. Between the autocomplete and the strict type checking, TypeScript makes uptaking unfamiliar code so much more straightforward than it would have been otherwise. And this is not an exhaustive list. There are so many reasons why I'm a huge fan of TypeScript. But especially when you're interfacing with external libraries, complex code that's been designed to handle a variety of use cases can often turn into complex types. The most wonderful, helpful, generic, and protective types that I love and am absolutely thrilled to have can sometimes be a little bit complicated to read. And sometimes when I open up a file to see these complicated types, get a little bit spooked, like this cat. This is what I call a TypeScript nope. It's when you see a type, you want to learn more about it, so you command click to go to the type definition, takes you to an unfamiliar file. The type is so long and scary and you have no idea what's going on. You debate with yourself whether or not you actually need to understand the type or if you can just go about your day, pretend like you never even saw it, and then you end up closing the file in a big nope and decide to deal with it later. Is that just me? I don't know if it's just me. But I've stumbled across various different types of TypeScript nopes throughout my years using TypeScript. There's the nope, this has way too many unfamiliar characters, I don't know where to start. Or the why are there so many letters, I don't know what they mean, nope. Or maybe it's just got a lot of TypeScript magic words that you're not sure what they do, are these new, I don't know. Maybe it's a really long, scary ternary that you don't know how to parse because it's so nested and deep. Maybe it's just a big old nope because it has all of these things in one type and you're not really sure where to start and you're not really sure how to break it down. Or my favorite nope, the oh my gosh, they disabled the max line length because these types are so incredibly long. Well, the good news is that TypeScript, like most things in life, gets easier to break down and understand with practice. Maybe you're already really comfortable with TypeScript and those examples that I just showed did not faze you at all. That's awesome. But if you're new to TypeScript or still getting the hang of it and they were a little bit intimidating, I want to let you know that it does get easier. But even 7 years later, for me, I still come across types that are big old nopes for me and they take me a little bit of extra time to break down and understand. So what I want to do in this talk is break down some complex types that I've found out there in the real world. I've adjusted them a little bit to make them make sense for this talk. But other than that, these types are either from the TypeScript documentation or popular libraries like Lodash and Ramda that I found on Definitely Typed. Okay, the first type that I want to break down has a lot going on. It's not necessarily a big type, but it's got a lot of parts. And oftentimes one of the hardest things about TypeScript is just knowing what to call these different parts so that you can look them up and understand what's going on. So this type has a generic type, a union type, and a conditional type. To break it down, I just want to spread it out and make it a little bit easier to read. And then let's dive into this generic. Generic types are incredibly useful for making types more generic, and for that reason, you see them all over TypeScript, especially libraries. A generic is a stand-in representation for a type that is either provided as input or will be inferred by TypeScript. Here, type T represents a type that the consumer will provide as an input. All T's are enforced to be the same type. And something that I think is important about generics is that they're often notated with a single letter. You'll see a T or maybe a K and a V, maybe a U, but they absolutely do not have to be. So I'm going to name my generic something other than T. I'm going to fill it in with a name that makes a little bit more sense to me right now. Type passed in. Simple, exactly what it says is what I am interpreting it to be. Okay, now that we've got the generic looked into, let's talk about union types. Unions are a pretty fundamental type in TypeScript that are used to compose other types. And for that reason, if you're building up a complex type in TypeScript, unions will often be one of the building blocks that you see in these types. Here, a union can be a value that is one of many types. It can either be null or undefined or false or empty string or zero. So I'm just going to use the exact words that I just said and put that into our type so it reads a little bit more like a sentence. Then the last part of this type that we need to break down is this conditional type. So much like in JavaScript, how you have ternaries or like if-then statements, conditional types allow you to do an if-then type assignment. Here, the conditional checks if the type extends null or undefined or false or empty string or zero, and then assigns either the value false if that was true or true if that was false. So putting those words back into our type, we have type is truthy. If the type passed in extends null or undefined or false or empty string or zero, then the value that this type will give you is false, because that means the type is not truthy. Otherwise, the value is true, because that means the type is truthy. And what that gives us is a type that tells us if another type is truthy or not. So if we were to pass in the string literal hi as a type, we would get back true, because that type is truthy. If we were to pass in null, we would get back false, because null does extend null or undefined or false or empty string or zero. So our value that we get back is false, because null is not truthy. Okay, and just like that, we've taken a type that had a couple different parts and successfully broken it down, so hopefully it was a little bit easier to understand and read. Now the second type I want to take a look at is this type omit. It might look a little familiar to some people. Omit has quite a few things going on. We've got multiple generics, we've got a couple utility types in here, and we've got multiple keyof operators. First thing I want to do, spread it out and fill in the generics, because we've already talked about that. There are two generics in this type. I called the first one type passed in, and I left the second one as k passed in, because I'm not 100% sure yet what that generic is representing. So let's investigate it. Here we have a keyof operator. Keyof creates a union type from the keys of the provided type. So here we're going to get keyof type passed in, gives us back all of the keys of that type passed in as a union. So if we have an example type that has A string, B number, C array of string, we run keyof on that example type, we're going to get back the keys A, B, and C as strings in a union. Then when we combine that with extends, what we're saying is that k passed in must extend those keys, or in other words, be like a subset of those keys. Otherwise, the extension does not pass. So I've updated the k passed in generic to be keys of type passed in to omit, because that's really what we're going for here. The first generic is a type that we're passing in. The second generic is some keys of that type passed in that we are actually trying to omit with our type. I've also filled in the keys in the exclude statement. I've just changed the first part to be union of type passed in keys, because that's what we get from the keyof operator. Okay, so now we've got some utility types here. Utility types are globally available types that represent common TypeScript transformations provided by TypeScript. There are two here, and I want to start with the inner one and work our way out. The inner utility type is Exclude. Exclude is a cool type that returns a new type minus any union members that match the union that you're trying to exclude. So here, we will get a union of all of the keys of type passed in, excluding the keys of the type passed in that we're trying to omit. So if the keys of type passed in, again, are A, B, and C, and we want to exclude B, because that's the key we're trying to omit, we will get back a union of just A and C. Now that gives us the keys we're looking for, but how do we get back the type? And that's where pick comes into play. Pick returns a new type with only the properties that match the keys that you've told it to pick and keep. So here, we're going to get a new type that is type passed in with only the keys to keep that get returned from our exclude statement. So remember, we excluded B from the keys of type passed in, and we got A and C as a union. Now we're going to pick A and C from our example type, and that's going to give us back a new type with just A and C. And this is the exact behavior of omit. If this looks familiar to you, it's because omit in itself now is a TypeScript utility type. If you want to use omit, you don't have to define it, you can just use it. But omit as a utility type wasn't added to TypeScript until version 3.5, I think. So there are so many instances of omit indefinitely typed in various different forms because it's a really useful utility. And so it was a popular type to create before it was part of the TypeScript utility core. All right, now we've successfully broken down maybe a more familiar type of omit that you can build yourself with various different pieces to give us the TypeScript utility type that we know. That takes us to this type, which I call what the heck are all of these words? Are they new? I don't know what's going on. We have a lot here. We've got more generics, multiple generics. We have some type inference, and we have another conditional type. So filling in what we've already talked about, I've spread it out. I've filled in the generic that we know about and the conditional type. So what we have here is our type valid double object. If type passed in extends whatever this is, then the value is whatever u is. Otherwise, the value is never. And never just represents a type in TypeScript that will not ever happen, will not ever be possible. But what exactly is all of that object situation? So here we have type inference, and you're probably familiar with type inference. If you were just typing normal TypeScript code and you typed like const a, you were defining a new constant. If you didn't directly explicitly tell TypeScript what type a is, TypeScript would take all of your code and all of the context that it has to infer what it knows a to be. And if it can't infer it, it'll likely tell you that you've made some sort of mistake. So here we have similar behavior. The generic type u will be inferred based on the type passed in. So if the type passed in extends this same object structure with a type, b type, and TypeScript can successfully infer u, then the extend statement passes. So if we have an object type that is a string, b string, we try to run that through our object matcher, TypeScript will infer u to be string because it matched the type structure, and it can successfully say that, okay, those u's are stand-ins for string. So I'm just going to make the u generic something easier to read. I'm just going to call it inferred type because that is what it means to me right now. So now we have, if the type passed in extends our object matcher and TypeScript can infer us a type, then the value that we're going to return is the inferred type. Otherwise, the value is never, because we don't want that to ever be a case. So running this through some examples, if we were to pass in the type string to our valid double object type, we would get back never, because string does not successfully extend our object matcher, and there's no inferred type to be had there. But if we were to pass in our a string, b string type, then we would get back the type string, because a string, b string does successfully match our object matcher, and TypeScript can infer the missing type to be string. Now, infer isn't something that I see very often. It's not super common, at least in my experience. So sometimes when I stumble upon it, it takes me an extra second to really parse it out in my brain to figure out what's going on. but I think we've successfully done that with our valid double object type. Okay, so we've made it to the big one, the just nope, the nopiest of all nopes, I guess. We have our type valid keys. So many things going on here. We've got a mapped type, a utility type, a map type modifier. We've got generics literally everywhere. We've got type inference. We've got nested conditional types. We've got keyofs, like just a lot all nested in this one TypeScript type. Also want to point out, after I've broken it out, we have our exclude type. We have our isTruthy type from the first example that tells us whether or not a type is truthy. We also have our object matcher that is going to infer us a type based on whatever gets passed in to there. All right, I've gone ahead and filled in the generics and the conditionals and the inferred types and everything that we already know so far. But I left in one generic K because I'm not 100% sure yet what K is representing here. Turns out it is a mapped type. So I think of map types similar to mapping over objects or arrays, but basically it'll return a new type with all of the keys in the key iterator mapped to some sort of value that gets decided later on in the type. So here we're going to map over all of the keys in the type passed in, and we'll be assigning a value later on in the type. So if our type being passed in had the keys A, B, and C, we're going to map those keys to a new type and give them a type value. Now that sounds great, but what is this like minus dash question mark situation? This is also not something I see too often. And the first time I saw it, I genuinely thought it was some sort of typo because it doesn't look like it belongs, and it's also pretty difficult to Google. But it turns out it's a map type modifier. So there are a handful of these modifiers in TypeScript, and they will be applied to a type as you map over it. So here we're going to remove the question mark or the optionality from every property as we map over it. So each property will no longer be optional, and therefore it cannot be undefined. So here, if we have our example type and A is optional, B is not, when we run it through this map type, we're going to get back A and B, but A is no longer optional and therefore cannot be undefined. Okay, so I've turned the map into words, make it a little bit easier. I've called our K generic key of type passed, and we were using that key to index back onto the type in this exclude statement. So I've called that value of type passed in, because that's what you get when you take a key and index it back onto a type. You get the value that that key went with. Okay, I want to take an example pass through this type because even though it's in like more plain English, it's still a little bit difficult to think through. So I think an example might be able to help us out. Here we have an example type. It has one key value on it. Valid1 is the name of the key, and the value that that type is A string, B string, or null. First thing we're going to do is that we're going to start mapping over this type. This type only has one key, so we're going to get a new type with that key mapped to a type to be determined. Then we're going to exclude null from the value of our type passed in. So remember, the value of our type passed in was the object A string, B string, or null. We're going to exclude null. And the reason why I'm doing that is because we're about to run this type through a couple of validation checks. And I don't really want to validate against null. It's okay if people pass in null for the type for this type. So we're going to exclude null from the type value so that we don't have to run null through the validation logic. So we're going to exclude null from the value of our type passed in, which in this example is just going to give us back that object type A string, B string. If that value, A string, B string, extends our object matcher and TypeScript can infer us a type, which in this case is true, then we're going to take our inferred type, which was a string, and we're going to run some additional checks on it. So if the inferred type is truthy, which in this case it is a string, and we're checking this because if the inferred type were like undefined or null or empty string or, that wouldn't be valid in our case. So if the inferred type is truthy, which in this case it is because it's a string, then the value that we're going to map to is the key itself as a string. So what that's going to give us is a type where the valid keys are mapped from the key to the name of the key. Then lastly, we want to get back just the names of the keys, which we've set as the value. So we're going to use the keyof to index back onto the type to give us just the values, in which case is the names of the valid keys. So we're going to get back just the string valid1. Altogether, given this example type, when we run it through our valid keys type, we're going to get back the string valid1 because valid1 is a valid key. And now this type is extremely powerful because we can throw all sorts of types at it and it'll tell us whether or not those types are valid and the name of the key that is valid. If I were writing a library, I could use this to protect consumers against doing things that they shouldn't be doing. So here we have our example type with a bunch of different types on it. We have valid1, which is the example we just went through. Then we have valid1, which is the example we just went through. Then we have valid2, which is also valid because A number, B number does correctly extend our object matcher. TypeScript infers the inferred type to be number, which is truthy. So valid2 is a valid key. Then we have invalid1. Now, invalid1 is invalid because it is optional, which means that in this case, it can be A string, B string, or undefined. Undefined doesn't make it through all of our validation logic, and because we're stripping off optionals in our modifier, invalid1 becomes never because it is invalid, so it does not make it onto our valid keys. Then we have invalid2. Invalid2 is not valid because the object does not match our object matcher. TypeScript can't infer us to type, so invalid2 is also not valid. Okay, so that was a lot. That was a really big type that had like so many different pieces building up this larger complex type. And it was a lot because TypeScript can be perplexing. But with practice, every TypeScript type can be broken down and decoded. So I hope no matter like what level you are in TypeScript, I hope you're able to take just one thing away from this talk that helps you break down a TypeScript nope that you run into in the future. If you have any questions or just want to chat about TypeScript, please feel free to find me on Twitter at Daria Caraway. Thank you so much.